What happens if you stare into a black hole for just 10 minutes? It sounds like a simple question, but the answer will stretch your mind to the very limits of physics and reality. Forget everything you think you know, because we're about to embark on a journey that defies common sense. First, let's set the stage. Imagine you're in a highly advanced spaceship, hovering at what's considered a safe distance from a supermassive black hole, let's say just outside its accretion disk. This isn't just any black hole. It's a cosmic monster millions of times more massive than our sun. Even from here, the view is spectacular. A swirling, incandescent disk of gas and dust, heated to millions of degrees, orbits the black hole at nearly the speed of light. This is the material the black hole is feeding on. It's the last scream of matter before it vanishes forever. The center, however, is a region of perfect, absolute darkness. The event horizon, the point of no return. You decide to start a timer and just watch for 10 minutes. What could possibly go wrong? As your 10-minute observation begins, the first thing you'd notice is something straight out of science fiction: gravitational lensing. A black hole's gravity is so immense that it bends the fabric of space-time itself. This means it acts like a giant, cosmic magnifying glass. The light from stars and galaxies located directly behind the black hole is warped and distorted, creating strange rings and arcs of light known as Einstein rings. You'd see multiple images of the same distant star, smeared and twisted around the black hole's silhouette. It would be like looking through the universe's most powerful and most terrifying funhouse mirror. The entire sky would appear to be wrapped around this central point of nothingness. But let's make this more personal. Say a friend of yours is on another ship, much farther away from the black hole, watching you through a powerful telescope. For them, your 10 minutes would look very, very different. This is where Einstein's theory of relativity really kicks in, specifically the concept of gravitational time dilation. The stronger the gravity, the slower time passes. Since you are much closer to the black hole's immense gravitational pull, your clock is ticking slower than your friend's clock. So, as you casually watch the cosmic light show for what feels like 10 minutes to you, your friend would see something bizarre. From their perspective, your movements would appear to be in slow motion. If you waved at the 5-minute mark of your timer, it might take hours or even days for that wave to complete from their point of view. When your 10-minute timer finally beeps, your friend might have been watching you for decades, centuries, or even millennia, depending on how close you are to the event horizon. For you, it's a short coffee break. For the rest of the universe, ages have passed. You have effectively time-traveled into the future. Let's up the ante. What if you're not just looking, but you accidentally drift a bit too close? As you approach the event horizon, the effects become extreme. The tidal forces are unimaginable. A black hole's gravity doesn't pull on you uniformly. It pulls more strongly on the parts of your body and your ship that are closer to it. If you were falling in feet first, the gravitational pull on your feet would be exponentially stronger than the pull on your head. This differential pull would stretch you out like spaghetti. Scientists have a wonderfully descriptive name for this process: spaghettification. Your ship would be torn apart atom by atom, and so would you. It's not a pleasant thought, but it's the stark reality of getting too close to such a powerful object. But let's assume your ship is magically indestructible and can withstand these tidal forces. As you get closer, the gravitational time dilation becomes infinite. From your friend's distant perspective, as you approach the event horizon, your image would appear to slow down, become redder due to gravitational redshift, and eventually freeze, seemingly stuck on the edge for all eternity. They would never actually see you cross it. The light from you would take longer and longer to escape the gravity well until it just stops. You would fade away into a static, red-shifted image imprinted on the edge of space-time. For you, however, the experience is completely different. There's no dramatic barrier or sign that says, "Welcome to the black hole." You would cross the event horizon without even noticing the exact moment it happened. It's a one-way door in space-time. Once you're past it, there is no escape, Not because you lack a powerful engine, but because inside the event horizon, all possible future paths lead to one place: the singularity. Space itself is flowing into the singularity faster than the speed of light. Trying to fly back out would be like trying to swim upstream in a waterfall that's faster than you can swim. It's physically impossible. So, what do you see in the final moments inside the black hole after crossing the event horizon? This is where physics as we know it breaks down. Our current theories, both general relativity and quantum mechanics, can't fully describe what happens at the singularity, the infinitely dense point at the center. Some theories suggest the singularity is a point of infinite density and zero volume. Others propose that it might be a gateway to another universe or a white hole that spews matter out. But your perception would be utterly warped. Since all paths lead to the singularity, the very concepts of up, down, left, and right would become meaningless. The singularity wouldn't be a place you travel to, but an event in your future that is unavoidable, much like next Tuesday is for us. You wouldn't see it as a point in front of you. Instead, you might see the entire history of the universe, from the Big Bang to its end, flash before your eyes in an instant, as time and space become completely intertwined and distorted. Or you might see only absolute crushing darkness as you are compressed out of existence. We simply don't know. It is the ultimate unknown, the point where the laws of the universe cease to apply. So, let's rewind. You've just finished your 10 minutes of observation from a safe distance. You turn your ship around and head back to Earth. For you, it's been a short, mind-bending trip. But when you arrive, you'd find an Earth that is thousands, or perhaps millions of years in your future. Everyone you ever knew would be long gone. Human civilization might have evolved beyond recognition, or it might not exist at all. The entire history of humanity could have played out during your brief observation. So that 10-minute glance into the abyss would cost you everything you ever knew. You'd become a relic of a bygone era, a living fossil. The question, what happens when you look into a black hole for 10 minutes, isn't just a physics problem. It's a profound thought experiment about time, reality, and our place in the cosmos. It shows us that the universe is far stranger, more wonderful, and more terrifying than we can possibly imagine. Thank you so much for joining me on this journey to the edge of reality. If you enjoyed having your mind bent, don't forget to hit that like button and subscribe for more cosmic adventures. Let me know in the comments what other mind-boggling space topics you'd like to explore. Until next time, stay curious.